Okay, turn to the back of page 106, and we're just going to review a couple really basic things before we talk about finding sine, cosine, and tangent in different quadrants. And the first thing is rationalizing fractions. We touched on this a little bit, but rationalizing a fraction means getting any square roots out of the denominator. So in the first one, I have a square root of 3 in the denominator. So that means that I want to multiply by a square root of 3 to get rid of that. But I can't just multiply the denominator by the square root of 3. I have to multiply the numerator by the square root of 3. And that will give me 2 square root of 3 over square root of 3 times square root of 3 is just a plain old 3. So that ugly hot mess is my rationalized fraction. In B, I need to multiply by square root of 2 over square root of 2, which is just 1, so I'm not changing my number at all. So that leaves me with 2 square root of 2 over 2, and my 1's reduce to 1. My 2's reduced to 1, so I get square root of 2. Next one, I have the square root of 5 in the denominator. So I need to multiply by square root of 5 over the square root of 5. So that gives me 17 square root of 5 over 5. And there's nothing I can do to simplify that, so that's the end. Oh, look at the end. I have square root of 4. What is the square root of 4? It's just 2, right? So this will simplify to 2 over 2, which is just 1. The last thing that we just need to review real quick is sine, cosine, and tangent. This is where we're going to use SOHCAHTOA. So if I want to find sine of alpha, that's how we say that, alpha, then I look where alpha is in my triangle, and I want to write the opposite leg, which is 12, over my hypotenuse, which is 13. If instead I want to find cosine of alpha, I need to look at the adjacent leg, 5, over the hypotenuse, 13. And then my tangent is opposite over adjacent. So looking at alpha again, the opposite side, the opposite leg would be 12, and the adjacent leg is 5. So tangent of alpha would be 12 over 5. Now we're going to switch gears, and we are going to look at beta. That's what that B is called, beta. So looking at beta, if I want to do sine, that would be 5 over my hypotenuse, which is 13. If I want to do cosine of beta, that would be my adjacent leg of 12 over my hypotenuse of 13. And tangent is opposite over adjacent, so that would be 5 over 12. So if you notice, when I go from alpha to beta, my tangent just flipped. They're reciprocals of each other. And my sine and cosine switch places. Alright, so that's just a quick review that will help us as we go on and talk about how to find sine, cosine, and tangent in other quadrants. So this type of problem looks something like, if you're given sine of theta equals 3 over 5, and you're told that theta is between 0 and pi over 2, can we find cosine of theta? So what we want to do, first of all, is decide what quadrant we are looking at. Sometimes it'll tell you the quadrant. Otherwise, it'll give you a little interval like this. So 0 to pi over 2, that means we're talking about quadrant 1. And it tells me that sine is 3 over 5. So that means the opposite side is 3. And my hypotenuse is 5, and I want to know what is x, or what is cosine. This is a right triangle, so I can just use my Pythagorean theorem. So 3 squared plus x squared equals 5 squared. So that would give me 9 plus x squared equals 25. So x squared equals 16, which means x equals 4. And our question is cosine. So if x equals, if we have a 4, 3, 5 triangle, I want cosine, which is adjacent leg over hypotenuse. So my answer for the whole problem would be that cosine of theta is 4 over 5. So basically we're just going to draw a triangle and then use the Pythagorean theorem. When we're talking about trig, this is called the Pythagorean identity, which is cosine squared plus sine squared is equal to 1. We're basically saying that the x, or a, squared plus y, or b squared, equals my radius squared, or equals c squared. Okay, so find cosine if sine of theta is 2/3 and theta is between 0 and 2 pi. So once again, we're looking in the first quadrant, so I'm just going to sketch my little picture here. And theta is always measured kind of like the inside of the bow tie we talked about before. So let's label. If I have sine is equal to 2 over 3, so that means the opposite side is 2, and my hypotenuse is 3. So first I need to find x. So I write my Pythagorean equation. X squared plus 2 squared equals 3 squared. So x squared plus 4 equals 9. So x squared equals 5. So x equals the square root of 5. Add that to my little triangle. And go back, reread your question. I want to know what cosine of theta is, so I need adjacent over hypotenuse. So that means cosine of theta is equal to my adjacent side, which is square root of 5, over my hypotenuse, which is 3. Last example. Find tangent of theta if sine of theta equals 3 over 7 and theta is between pi over 2 and pi. So pi over 2 and pi, we're talking about quadrant 2. Okay, so let me sketch my triangle. Boom, boom, boom. Remember, theta is like the bottom part of the bow tie, so there's the angle we're talking about. It gives me sine. Sine is opposite over hypotenuse. So that means my side here is 3 and my hypotenuse is 7. So first I need to find x. So I say to myself, x squared plus 3 squared equals 7 squared. So x squared plus 9 equals 49. So x squared equals 40, and I'm going to do the square root. Now we do need to simplify this. OMG factor trees. I see that as 8 times 5, which is 4 times 2. And 4 is a perfect square, so I could take this out as 2 square root of 10, because 4 is really 2 times 2. So I take out a pair of 2's and I'm left with a 2 and a 5 underneath. So x is equal to 2 square root of 10. Let's label that baby over here on my graph. 2 square root of 10. And my question is tangent. So make sure you go back to the question. Tangent. So that's opposite. So in this problem, my opposite would be 3 over adjacent, which is 2 square root of 10. Now, do I want to have square root in the denominator? No. So this is why we rationalized at the beginning. So I need to multiply by square root of 10 over square root of 10, which would leave me with a hot mess of 3 square root of 10 over 2 times 10, which is 20. Because remember, when you multiply those radicals together, they will undo each other. So square root of 10 times square root of 10 is just a plain old 10. 10 times 2 is 20. So that, I'll just write that out again. So 3 square root of 10 over 2 times 10. Whoops. Will not let me do a times. There we go. 2 times 10. That's how I got 20 in the denominator. So that gross answer is what I'm going to do. So to summarize, I'll just go ahead and add this. Identify your quadrant. Then we want to draw our triangle. Oh, I forgot something. What kind of x is this going to be? It's going to be a negative, which means it's really 3 over negative 2 square root of 10. So my final answer is negative, which I realized when I was writing my instructions. So draw your triangle, label our given information, solve for your missing side, and we're going to really make sure we watch our negatives, because that's what I got carried away with. Watch our negatives. Okay. And lastly, answer the question. Okay. So we identify our quadrant, draw the triangle in the quadrant, label with given info, solve for your missing side using a squared plus b squared equals c squared, watch your negative signs, and finally answer whatever the actual question is that they are giving you.